Good morning dear students, welcome to the new session of Standard 9 Physics, Chapter Gravitation, Part 3. Content: Inverse square rule, Newton's third law and gravitation, free fall, acceleration due to gravity. Next, inverse square law. Actually, Kepler gave the laws of planetary motion, but he could not give a theory to explain the motion of planets. In such a situation, Newton developed universal law of gravitation with the help of Kepler's third law. Let us discuss the derivation. Clear? Yes. Dear students, let us discuss the derivation. And here, an important thing is that in the case of Kepler's law, we know that he just introduced an elliptical orbit, but in the case of inverse square rule, Newton considered a circular orbit instead of an elliptical orbit. Clear? And consider a planet of mass m moving with a velocity v around the sun in a circular orbit of radius r. Here, in this case, the centripetal force is provided by the sun. Clear? Yes. The centripetal force F is equal to mv square by r. M means mass of the planet, v is the velocity of the planet, and r is the radius. Therefore, centripetal force F is equal to mv square by r can be taken as equation number 1. Here, the mass of the planet is a constant, right? Yes. Therefore, equation 1 can be written as F proportional to v square by r, because we are removing this mass m from here because it's a constant. Then the equation 1, which becomes F proportional to v square by r, can be taken as relation number 2. T is the time taken by the planet to complete one revolution around the sun. Then the velocity, which becomes v is equal to 2 pi r by t, means the body or the planet which moves in a circular orbit. The planet moves in a circular orbit. Therefore, the velocity can be taken as what? The circumference of the circle. Therefore, v is equal to 2 pi r by t. 2 pi r means the circumference of the circle, and t is the time taken to complete one revolution. Therefore, v is equal to 2 pi r by t can be taken as equation number 3. Here, this 2 pi is a constant, right? Then equation 3 can be written as v proportional to r by t, because we are moving this 2 pi from this equation. Then which becomes v proportional to r by t. It can be taken as relation number 4. Then square on both sides. Then square relation number 4 on both sides. Then you will get v square proportional to r square by t square. Then multiply as well as divide the right side of the relation by r. It becomes v square proportional to r square by t square into r by r, which means v square proportional to r square into r means r cube divided by t square into r. It can also be written as v square proportional to r cube by t square into 1 by r. Relation number 6. According to Kepler's third law, r cube by t square is a constant that we have already discussed in the previous slide, right? Therefore, relation 6, which becomes v square proportional to 1 by r, because r cube by t square is a constant. Clear? It can be taken as relation number 7. Then, by putting 1 by r in place of v square in relation 2. Relation 2 means this one. In this relation, we are replacing this v square by giving 1 by r. Then the equation which becomes f proportional to 1 by r into r. Instead of v square, we are giving 1 by r. Therefore, f proportional to 1 by r into r, that is f proportional to 1 by r square. Which means that the gravitational force between the sun and a planet is inversely proportional to the square of the distance between them. Clear? So very important. expression. Okay. And it is also the second statement in the universal law of gravitation. Universal law of gravitation means every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So the second statement means the force between two bodies is inversely proportional to the square of the distance between them. Right? Yes. Next, Newton's third law and gravitation. Newton's third law of motion says that to every action there is an equal and opposite reaction. This law can be connected with gravitation. This means that when Earth exerts a force of attraction on an object, then the object also exerts an equal force on the Earth. So you just consider this example, a stone and earth. You are just releasing stone from a particular height. Here you can see that the stone is moving towards the earth. Why? Because the gravitational force provided by the earth attracting this stone towards its center, or simply gravitational force provided by the earth. Therefore, the stone is moving towards the earth. Right? So according to Newton's third law, to every action there is equal and opposite reaction. Which means what? Here the stone is attracted by the earth. At the same way, the earth should be attracted by the stone. But we are not seeing that the earth is moving towards the stone. We are always seeing that the stone is moving towards the earth, not the earth is moving towards the stone. Why? What is the reason? So this situation is just connect with this formula. F is equal to ma. F means force, m means mass, a is acceleration. So F is equal to ma. So just rearrange this equation as acceleration a is equal to F by m. And you just consider two quantities, acceleration and mass. Here the acceleration is inversely proportional to mass, right? Because here the mass is in the denominator. So acceleration is inversely proportional to the mass, which means what? A lighter body which moves with greater acceleration and a heavier body which moves with a less acceleration. Right? You just connect this idea with this particular situation. How? Here the stone is a lighter body, which means less mass. It should have greater acceleration. Here it is correct, right? Stone is moving towards the earth with a greater acceleration. At the same time, the earth has higher mass, right? Or earth is a heavier body as compared to the stone. The mass is heavier means acceleration should be less, because acceleration is inversely proportional to the mass, right? So in the case of earth is a heavier body means earth has greater mass, therefore it moves with a less acceleration. Clear? Yes. That is why we are not seeing that the earth is moving towards the stone. Next, free fall of a body. Free fall of a body means the falling of a body or an object from a height towards the earth under the gravitational force of earth with no other forces acting on it. And it is what we call free fall of a body. Means we are just releasing a body from a particular height and the body is moving towards the earth because the earth is attracting this body towards its center, right? And if no other forces are acting on the body will easily reach the ground, right? And it is what we call free fall of a body. It's a very simple idea. Clear? Yes. Next, acceleration due to gravity. When an object is released from a height, its velocity increases at a constant rate. That is the first point. Second point, uniform acceleration is produced in the body by the gravitational pull of Earth. The uniform acceleration produced in the body due to the gravitational force of Earth is known as acceleration due to gravity. It is a very important point Once again, the uniform acceleration produced in the body due to gravitational force of earth is known as acceleration due to gravity, and it is denoted by the letter G, small letter G. The value of G is 9.8 meter per second square because it is acceleration, therefore the SI unit is meter per second square. Value of G is 9.8 meter per second square. And this value of G does not depend on the mass of the body. That is also a very important point. So these are some basic ideas about acceleration due to gravity. Clear? Thank you, dear friends. Next time we'll meet with another topic. Till then, bye.